Let's face it, one of our key jobs in this course together, you and I, is to make sure that we can build or design, that's pick out, a computer that is going to be incredibly powerful for someone. How much power they need is really going to vary based on what they're doing, so that would be a key part of our interview process. One ingredient, obviously, is going to be the central processing unit, or CPU, that we are going to select for their system. Remember now what's going on. Let's say we have someone that wants to do some editing of a photograph inside of Photoshop. So here's their wonderful photograph. That's going to be pulled in off of storage. So storage and the speediness of storage is certainly a factor in what someone's going to perceive as the power of their system. We know it's going to be stored in random access memory as they're working on that photograph, but as they are manipulating it, the speed at which things can be done is going to be in part dictated by the central processing unit. The central processing unit is the brains of our computer. It's where all the calculations are taking place so that we can do things like modify the individual pixels that make up a photograph inside of Photoshop. So notice, when we talk powerful computing, we are not just talking about a powerful CPU. There are other ingredients that come into play. Now, different things are really going to have different requirements when it comes to power. I'm a private pilot, and one of the things I love to do is fly simulations so I can train right in the privacy of my own home. It's a lot friendlier on the environment. It's a lot friendlier on my pocketbook to train right in my office. So I purchased this excellent machine that you'll meet in this course for the exclusive job of flight simulation. Now, one of the flight simulators that I use is called X-Plane, and the version I'm on is X-Plane 10. So what would be the minimum requirements? Well, look at what's listed first. It's the processor. I need at least a dual core 2.5 gigahertz or faster processor. And at the end of this nugget, you'll know what all that means. I need 4 gigabytes of RAM, and I need a video card that has at least 1 gigabyte of specialized video RAM. We would never build a system with these minimum requirements, though. I can tell you from experience that my flight simulation experience would be awful if I used these settings. So we like to go to the recommended system settings. Notice it's a quad-core processor at 3 gigahertz or faster, 16 to 20 gigs of RAM, and then a DirectX 11 capable video card with at least 4 gig of onboard dedicated video RAM. So we are going to be focusing on the processor part of this equation, and we are going to see how advancements in processors can make incredible applications like glorious flight simulators possible. Boy, you'll have to remind me, because at some point in these nuggets, I'll have to do a little demonstration of the flight simulator in action for you. I probably should have paid attention in that college economics class I was forced to take, because I would probably know why there tends to be two giants in any industry. Think about it. There's Coke and Pepsi. There's McDonald's and Burger King. And in the world of CPUs, there's Intel, the market leader, and then a company called AMD that chips away at their lead. Whew, what a great unintentional pun. Now, when it comes to form factor that these companies make, there's 3 that are classic. And these 3 are depicted here, kind of. Let me explain. There's a land grid array, not to be associated with a golf LGA, by the way. I think that's the Ladies Golf Association. But anyways, the land grid array, I am showing the socket for that here because I wanted to show you where the pins are located. See all the pins in here? Look at all those pins. Woo! So the chip itself is placed in this square. Then we lower this latch. Notice there's a latch up here and there's a lever down here. So we gently place the chip in there that has contacts for those pins, then we lower the cover and secure the latch, and that's how we install a LAN grid array style CPU. What about the pin grid array? Well, as you might have guessed, the pins are on the CPU itself. So in the socket, there will be receptors for that style of CPU. And then there's the single edge contact cartridge, and we're familiar with these. We see this type of technology when we have expansion cards in our device. So we're going to have contacts along one edge, single edge contact, makes sense, and then our circuitry for the CPU will be protected within that circuit board. And now that you're familiar with these three form factors, we begin to appreciate the interrelatedness of the CPU. We begin to appreciate another compatibility type portion of this course. Think about it. You're going to have a motherboard. That motherboard is going to support a certain type of socket. That socket is going to support a certain type of CPU. That certain type of CPU is going to support certain types of RAM. You get the idea. So we have to be very careful when we are picking out a PC if we're going to build it from scratch, because we have to ensure the compatibility of all of the different parts. When we go to a manufacturer for a PC, a lot of this concern is offloaded for us. We may pick the speed and the number of cores of the PC, and then they'll allow us to outfit it with the appropriate amount of RAM. And when I say appropriate amount, that's going to be variation, but they'll pick the RAM for us that works with that particular CPU. Now, it turns out that Intel is a big fan of the LAN grid array style of chip. So with their CPUs, they're going to have all these different types throughout the years of LGA sockets that we could have on a motherboard. Here's an LGA 775, and over here is an LGA 2011. What do those numbers represent? Well, you can see it with the naked eye. The LGA 775 represents the number of pins that are in that socket. So we have 775 of them right here. We could almost count that, I suppose. And then it would be very difficult for you to count the 2011 pins that we have with the socket shown on the right. Now, what's super interesting about this, and you would never want to try and memorize it, of course, is that each of these sockets represents advances in CPU technology. For instance, the LGA 2011 socket that we have depicted here just so happens to have been released around 2011, and it supported the Ivy Bridge and Sandy Bridge type CPUs. So it would literally force the retirement of other socket types that supported lesser CPUs as the CPU technology would continue to advance. By the way, what's this Sandy Bridge and Ivy Bridge all about? Well, as you can see from this Wikipedia article about the Intel Core, these are fun names that the Intel engineers will go ahead and assign. I suppose it's the Intel marketing department, really, but the marketing department will assign these names to their exciting new architectures. It reminds me of how Windows will assign code names to their operating systems as they're working on it. And a lot of different software and hardware manufacturers will do this. So we can see that something lately that's exciting is the Skylake microarchitecture, and this was launched in August of 2015 from Intel. So if Intel is a big fan of the LAN grid array style, then what's AMD all about? Well, they're a huge fan of the pin grid array style. So when you look at a particular socket like the FM2 Plus socket from AMD, you'll see we don't have pins sticking up from it. No, we have the receptors for the pins that are on the chip, as we discussed. You can see they follow a different naming convention for their sockets, but it's the same type deal, isn't it? A different socket from AMD is going to support certain chips that they manufacture, and certain socket types are going to fade away as new socket types come out to support the new CPUs, which support new and exciting functionality to give us more power and a better overall computing experience. Well, I'm really excited right now. In fact, I've got to take my flight simulator that I told you about, and I've got to slide the cover off, and I've got to look inside. I've got to see what type of socket that I have on my motherboard. And wait a minute here, what's going on? I can't even see the CPU or the socket. There's this Alienware cover covering it. There's these tubes coming out of it. What in the world is going on? I am blocked from even viewing my CPU inside this powerful PC. Well, you probably know what's going on. You see, as CPUs get more powerful, as they get more capable for us, they generate something that really is a bummer, and that's heat. So there has to be creative new ways in which to cool these powerful CPUs. And you can see I've got some new cooling technology taking place. You see hoses coming off that plastic casing. We'll discuss later on in this nugget just how we're going to cool these incredibly powerful CPUs of today. So we have the form factor, we have those sockets from AMD and Intel, very, very important information. But the most exciting part of this nugget for me is now, what are the characteristics of these CPUs today? And what characteristics would we target for a specific task? One of the first characteristics, we can't ignore it, when it comes to the CPU is speed. Speed is measured in the frequency with which calculations can be performed. When I started out in this industry, we were talking in terms of megahertz, but these days the CPUs are so incredible, they're at gigahertz speeds. If you look at the new iMacs, for example, from Apple, these are gorgeous machines, obviously. We go in and we go to buy, and we notice something very interesting. For the 21-inch iMac, there's various priced iterations of this product. There's one that has a regular old 21.5-inch display, and there's another that has a Retina 4K 21.5-inch display. But something else that's interesting right off the bat we can see is that the three models come with different speed processors. So notice at the high end, we're dealing with a 3.1 gigahertz processor. It's a quad core, we'll get to that in a moment, Intel i5 processor. It's got a turbo boost up to 3.6 gigahertz. So you can see speed is going to be expressed today in gigahertz, and faster is of course better. But many times it is not necessary for us to spend the extra money for a bit of enhanced speed. It's all going to depend on the intended use of that machine. And of course, how the particular vendor markets their things. For instance, if the 4K display here was the deal breaker for your customer, if they saw it in a store and now they absolutely have to have it at home, well then you're giving them the 3.1 gigahertz processor because that's the only config right now from Apple that gives them the 4K display. During the course of these nuggets, you will hear Anthony Sequeira talking about Apple devices, PC devices, Windows devices, Mac devices, Unix devices, Linux devices, various devices of all kinds from all manufacturers. Anthony makes no claims about any of these manufacturers. He loves them all. He does not cherish any one particular operating system, or they'll even do the dual quad core, giving you 8 CPUs total in just one CPU chip. AMD, interestingly enough, will literally go in odd numbers, so they will have a triple core type design in the AMD world. Now, something else that's going to dramatically impact the speed at which your device can compute is called the cache. This is a holding area while we're getting information in and out of something like a CPU. So you might have a level 1 cache, which is a temporary holding place as the information is entering the CPU. You might have a level 2 or back-end cache that's going to hold the information as it's on its way to what's next? RAM. The faster, the larger your caching capabilities, sure enough, this is going to boost performance. These days, there might even be a level 3 cache that is external to the CPU completely somewhere in your system, and its job is to enhance communications between RAM and the CPU even further. If you can think back this far, when the Pentium 4 came out, they started inventing a technology for these CPUs called hyperthreading. And this was so exciting. I can remember this at the time. I was super excited about this because hyperthreading inside of these CPUs would allow them to multitask better. For applications that were written to take advantage of this hyperthreading, you could have a lot going on simultaneously inside the CPU. Something else today that we really target is virtualization support with the CPU architecture. So many times today, we're shopping for a CPU and a computer motherboard setup that will allow us to easily virtualize other operating systems. Sometimes we'll even look to do what's called bare metal virtualization. Let me explain what this is. You take a server. Okay, so you have this server and you install no big operating system onto this server. Nothing. You don't install Windows on it. You don't install Linux on it. You don't install the Mac OS on it. You just install this tiny little hypervisor software package, and then on top of that, you can virtualize a whole bunch of different operating systems. So this one server can run all of the operating systems that I just described. This is wonderful as long as your chip supports virtualization. I want to show you something super interesting about the machine that I'm using right now to create this nugget. Notice this machine is a Windows 10 Pro system, and you can see the exact operating system build that I'm using. Of course, that's from Microsoft. The name of this machine, Nugget to Go, because it's a Wacom or Wacom tablet type computer. It's the Cintiq companion, and that's so funny. They've got the system model name misspelled. Hilarious. We'll talk about this x64 based PC in a moment, but look at the processor. It's an i7 chip, nice 1.9 gigahertz chip, and there's dual core technology inside it. So it sounds very exciting from a virtualization standpoint until you scroll down in the system information and you see that there is no virtualization enabled in the firmware. So even though this chip would be capable of virtualization, the firmware, the BIOS that's on this particular device does not permit virtualization. So watch out for this. I've got a chip that can do it, but I've got firmware written for this tablet that doesn't permit it. As you might guess, I've spoken to the Wacom people about this, and this is something they're hoping to correct for my model device. Now, what about that 64-bit thing? Well, there used to be 32-bit based processors, and now it's double that. It's 64-bit. It means that the system can literally deal with larger chunks of information at a time, and it can point to addresses that are larger chunks of information in physical memory. 64-bit is way better than 32-bit, as you might guess. Nowadays, all systems that you see being created, it seems like, are 64-bit. So what you want to do to take advantage of that is you want to target 64-bit operating systems and 64-bit applications. Let's say you've got a 64-bit PC and you installed the 64-bit Windows 10 on it, but then you have an older 32-bit application. That application is still going to work, but it really can't take advantage of the full architecture that you have in place. And finally, two more features that I want to discuss with you that you will find in CPUs today is an integrated graphics processing unit. This is specialized circuitry to make your graphics really sing. Around, I guess it was Windows Vista, they started adding all these cool like transparency effects and animation effects. They called it at the time the Windows Aero view. And Aero was spelled A-E-R-O. But to take advantage of that functionality, you needed special direct compute APIs and DirectX technologies, which would need an integrated graphics processing unit inside of your CPU to take advantage of that. This is so common now, we tend not to even worry about whether or not it exists. The disable execute bit is actually called enhanced virus protection if it exists in an AMD world, and this is telling us what the feature does. The disable execute bit is a technology that CPUs can use that will segregate areas of their memory for storing particular processing instructions. Why they're segregating it is to help reduce the vulnerability to certain types of malware and viruses right within the CPU's architecture. So let's wrap up this nugget by revisiting something we mentioned earlier. As the technology gets more sophisticated, more heat gets generated, and that becomes a big issue for the CPU, getting it cooled down. There are heat sinks. Now, a heat sink could be active and could have fans, or it could be a fanless type of heat sink, and it could be completely passive. A great passive heat sink example is when we have this metal that'll really conduct the heat really well. It'll grab the heat and suck it out of the component and dissipate it, and that metal is placed on top of the CPU. But wait a minute, do we just glue it there? We use something called a thermal paste oftentimes with this type of a technology so that we can make a nice, clean, very, very efficient connection between the heatsink and the CPU itself. You'll sometimes hear of it as like thermal glue, by the way, so don't be surprised if you hear a variation of this thermal paste terminology. You probably wouldn't do it if you were actively removing the heat with a fan. You wouldn't use thermal paste between the fan and the CPU, and that's simply because of the fact that fans are most likely going to have to be replaced at some point inside the device itself. So when we have something active like a fan that might need replacement, we're probably not going to paste it to the CPU. There's also newer technologies today, as you saw in my Alienware system, that might be liquid-based. How amazing! Advantages of liquid-cooled systems would be things like it's going to be much quieter than fans inside the system, and also when you're using liquid to cool your CPU, it's going to be much more efficient than simply using a fan. In my system, there's actually a combination of liquid and fans in use to give the most cooling possible. So the old CPU, yeah, I know what that does. It's a little chip inside the computer that's like the brains of the system. Well, now we know after this nugget that there's a lot more that goes on to something like the CPU. By the way, you know what a lot of people used to call the CPU? I've seen this many, many times. They call the tower, the computer itself, the whole case, the box that everything plugs into, they like to call that the CPU. You and I would never make that mistake. We know the CPU is nestled there on the motherboard, doing much of the magic that makes our computing experience happen. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.